gonna work homework 15.100. I honestly didn't look if I assigned it to you. I just thought it was interesting. So we have this system, and it's sitting on some bearings that attached to the ceiling and attached to the ground, and it's allowed to spin freely. Attached is this rod right here, and on each end is an equal mass. We'll call mass A and mass B. They are equal, and they're each 10 kilograms, and the distance from each to the center of rotation, this is our axis of rotation. The center to each ball is 0.5 meters, and they gave us that each one has an initial velocity in that transverse direction. It can only at any instance have a transverse component, right? The A and B cannot move in and out, in other words. How about that? Okay, and the path remains a circle, in other words. So the one thing they tell us is that a moment is applied, and we're just going to assume it's going in the positive direction, which is counterclockwise, and it's a function of t. It's t squared plus 2. Let's use impulse momentum theory to figure out how fast it's going when 3 seconds has gone by. So if that's the z-axis, I'm going to say h about z plus the summation of our moments, or the integral of our moments, which is the angular impulse from t1 to t2, and that's going to give us some new angular momentum. Okay, so we could do this two ways. We could say that each one of these is an RMV for RA mass A VA plus RBVB, oh, went out of order, MB. Or since we've realized that the distances are the same and the masses are the same, then we can just put a 2 out front and just call it a common RMV. Okay, so we want to integrate the moment to get the impulse, so it is a function of time. The integral of t squared plus 2 dt, and they asked after 3 seconds, which implies we're starting at 0, and we'll integrate up to 3. Don't forget the 2 on this side if you're going to do this method. Otherwise, your answer will be twice as fast, I think. We have the same R, M, but we have some new V. We'll just call 1v1 and 1v2. Alright, we can work this now. Taking the integral first, I get t to the third over 2 plus 2t, and we're going to evaluate that from 3 to 0. And 2 times 0.5 times 10 times 2, that's 20. And then 2 times 0.5 times 10 is 10, and then times v2. Alright, we can evaluate that and solve for v2. We're done. v2 then would be 3.5 meters per second, and that is the v at 2. So VA at 2 is equal to VB at 2, and that is 3.5 meters per second. Ta-da!